Good morning, everyone. I hope everyone is doing good. My name is Vibhakar. I'm a data analyst and a data science intern at Sparks Foundation. As a part of the internship, we were given a few tasks, and this is my first task of the Sparks internship. This is a prediction using a supervised machine learning method. We need to predict the percentage of a student based on the number of hours he or she is studying. Okay, so this is a very simple linear regression model. We only have two features. So this is the task. So this is my name and this is my badge. So task 1 is to predict your score based on the study hours you study. Okay, so we will be following these steps. We'll read the Excel sheet, understand the data, check the correlation, visualize and distribute the data. These are all the steps that we will follow, and we'll start off by importing the basic libraries. We'll read the Excel file, and this is how the sheet looks like. We only have two features, hours and scores. The shape of the data is 25, so we have 25 rows in two columns. We have float type values, and also score is an integer type value. And if I have to describe the data, so these are the hours. Some average hours are 5 hours, and minimum is 1.1 hour, and the maximum is 9.2. The scores are distributed like this. If I have to understand the correlation, they are very highly correlated, 0.97. And just to visualize the data, this is the hours, how they are distributed, and this is the marks of each student. So we have 25 students. The first student marks, the second student, third student, fourth student. We have 25 stars for the 25 students. You can see the 15th student has highest marks. So let's see the 15th student. So 95 marks, he is the highest marks. And this is the distribution of scores. This is the distribution of hours. And I've created a new column just to make the understanding more better. So depending upon their scores, we have divided the students between 0 to 40 marks are dull students, 40 to 80 average, and 80 to 100 are good students. So we created a new column, and depending upon that, again I've made a group by student and found their average scores. So the average score of a dull student is 25.9. the average student score is 59.3, and a good student average score is 87. Okay, and just to visualize it one more time, so dull students, this is the students and this is hours. So good students is studying more hours, average students are studying less hours, and dull students are studying very less hours. And it's clearly visible that that more the students study, better the student can be. Okay, and this is the scatter plot, just to find out how they are how both are related. So it's very strongly related. You can see again segregated by the dull students, average and good students. So we'll drop off this column because this is just for our analysis. So we'll drop off this column, and we'll go to sklearn library. We'll split x and y, and then do a train test split. This is our split, importing the linear regression and also the metrics, creating a linear object, fit the model, and you get a coefficient called m and an intercept called c. So in simple linear regression, basically what happens is you try to draw a line that passes through these data points which have very minimum distance from each data point. So that's basically the best fit line, you call it. So that line have a coefficient of m and an intercept of c. So once you do the fit, this is the value you get, this is the value of m, and this is the value of c. And for checking the error, how they are distributed, put a predict and error y test minus y prediction. This is our error distribution. Most probably it seems everything is taken. So this is the model evaluation. The training score is 95% and the test score is 90%. Okay, and this is the mean absolute error, mean square error, and root mean square error. So this explains how good our model fit. So to predict the line, as I said, we will draw a line with mx y equal to mx plus c. So this is our line. So this is the line that is having very much less error. Okay, And to predict the scores, I've created a function. So h is the number of hours you study and score is equal to m into h plus c. Okay, so if your score is if you're studying for 6.2 hours, your score will be 62.5. And if you're reading for 6.5 hours, 6.5 hours, your score will be 65. So in the task we were told this one, what will be predicted score if a student studies 9.25 hours every day. Let's do this. 9.25 hours every day, his score will be 91. Okay, so you can predict your score depending upon the number of hours like this. And this is a very simple linear regression, and I'm also uploading this video in my YouTube channel, guys. You can also check this out. Thank you.